Good morning to all. Myself, C. Kokila Priyadarshini, working as a assistant professor in Department of Information Technology in Mohambigai College of Engineering. Today, we are going to see about describing a data. Des- Types of data: qualitative data, ranked data, quantitative data. Qualitative data. Qualitative data consists of words, letters, or numerical codes, that is 0 or 1, that represent a class or category. Ranked data. Ranked data consists of numbers that represent relative standing within a group. Quantitative data. Quantitative data consists of numbers that represent an amount of or a count. To determine the type of data, focus on a single observation in any collection of observation. Describing data with tables. Frequency distribution for quantitative data. Frequency distribution for qualitative data. Frequency distribution for quantitative data is a collection of observations produced by sorting observation into classes and showing their frequency of occurrence in each class. Guidelines for frequency distribution. Each observation should be included in one and only class. Example here: 139, 140 to 149, 150 to 159, etc. It would be incorrect to use because 130 to 140 and 140 to 150, 150 to 160, etc. in which, because the boundaries of classes overlap, an observation of 140 or 150 could be assigned to either of two classes, any one of the classes only assigned. Next, list all classes, even those with zero frequencies. Example: as listed in table, in the class 210 to 219 and its frequency of 0, H would be incorrect to skip this class because of its zero frequency. All classes should have equal intervals. Example: 139, 149 to 140 to 149 and 150 to 159, etc. It would be incorrect to use 130 to 139, 140 to 159, etc. in which the second class interval 140 to 159 is twice as wide as the first class interval 130 to 139. Constructing frequency distributions. Find the range, that is, the difference between the largest and the smallest observation. The range of weights in table is 145 to 133, that is 112. Second, find the class interval required to span the range by dividing the range by the desired number of classes, ordinarily 10. In the present example, class interval equal to range divided by desired number of classes, that is 112 divided by 10, so 11.2. Round off the nearest convenient interval, such as 1, 2, 3 up to 10, particularly 5 or 10 or multiples of 5 or 10. In the present example, the nearest convenient interval is 10. Determine whether the lowest class should begin. Ordinarily, this number should be a multiple of the class interval. In the present example, the smallest score is 133 and therefore the lowest class should begin at 130. Since 130 is multiple of 10, determine whether the lowest class should end by adding the class interval to the lower boundary and then subtracting 1 unit of measurement. In the present example, add 10 to 130 and then subtract 1. The unit of measurement to obtain 139, the number at which the lowest class should be n. Working upward, list as many equivalent classes as are required to include the largest observation. In the present example, list 130 to 139, 140 to 149, 240 to 249, so that the last class includes 245, the largest score. Indicate with the tally the class in which each observation falls. For example, the first score in table 160 produces a tally next to 160 to 169. The next score 193 produce a tally next to 190 to 199 and so